Hello, welcome back to the series where we build our first LLVM language front end. This is a tutorial walkthrough of this tutorial that is found on LLVM.org. And there are two versions of the tutorial: the OCaml version and the C++ version. We're doing the C++ version. In this series so far, we've gone through 5 full chapters and then a little bit of the 6th chapter. We're gonna continue on with the 6th chapter. Last time we implemented the parser for the custom operators, and this time we're gonna implement the code generation for that. So let's do that. Okay, so we're gonna find this binary expression AST class, which that means there's a binary expression in the code, such as 1 plus 2. And now, since we're allowing custom operators, it can actually allow us to do like 1 at sign 2, and we can define the at sign to do whatever the heck we want, just like a function can, right? So we're gonna change the code generator for the binary expression to be able to relate to the defined code for that custom operator code. Yeah. So let's see how we're going to do that. So far we have code that looks like this. We're first gonna generate the LLVM code for the left hand side and then do the same for the right hand side. We're gonna then combine it with one of these operations: add, subtract, multiply. Do we even have divide? We don't have divide implemented actually, and actually we only have less than implemented, not greater than. That's interesting. But the case that we're going to add is this one. If it wasn't a built-in binary operator, it must be a user-defined one. Emit a call to it. So how are we going to do that? We're not going to error out if we don't find it, actually. So let me see. I see. We're gonna call this get function, which we previously wrote to find a function object by the name of the function. Okay. Oh, all 4 of these guys already return. That's why. I feel that it's better form to write this code inside this default case. That's just my preference. So to keep consistent to this pattern of returning within the switch statement, although I can see the argument the other way as well, that we're trying to not sort of make this switch statement too bulky. I think that's what he was going for. Okay, I'll follow his method. Okay. So the standard string the up is the operator. Okay, I see. If we have a function defined for a binary operator, then it would start with the word binary. So like if we define a custom, if we define the at operator, its name would be that. So this op would be the at operator. We're gonna concatenate it with the prefix binary, and that would be the name of that function in our system. So that's what we're doing. We have a little assert to make sure that function is found. If it's not found, it looks like it's just gonna error out. It's interesting that we're using a new method of reporting errors instead of returning a null pointer. That's probably just due to laziness. Okay. So these are the operands, I believe. The operands that go into the LLVM builder call. So and then we're going to use the builder to create call with this function object and a this ops, the operators, and this is going to be a bin op. I guess this is just a name. I think this bin op is just a name. Okay, so we did binary expressions, but we also need to do unary operations, I think. Or not. The final piece of code we're missing is a bit of top-level magic. Beautiful. I love top-level magic. Where is this now? Function ast Codegen. Okay. Transfer ownership of the prototype to the function protos map, but keep a reference to it for use below. Did we do that previously? Yes, we did do that previously. I might have like changed it a little bit from what they have here. So let me try to understand what has changed right now. So this is just to get the name so that we can call a get function to find the function. If it's a binary operator, install it. Oh, I see. We need to add this little bit of code. Function cannot be redefined. Okay. So if P, whatever P is, I need to use this weirdness just so that I can access P. I see. Okay, if it's a binary operator, we're gonna need to by install it, I think it means set up its binary precedence in this hash, in this bin op precedence hash. Oh shoot. I decided to deviate from the way they do it. So I actually do not have this binary hash because I decided to implement precedence using a switch statement instead of a hash map. So I'm gonna change it to use a hash map then, I guess. So if we had all right. You can refer to the code listing at the bottom, but I'm gonna try to do it myself just as an exercise. So I believe this is a global variable, and it's probably static. And I believe this is gonna be a standard map that maps something to an unsigned number, and that something is a character, probably. It maps a char to an unsigned, because get operator names, whatever get operator name is, yeah, it's a char. So it maps a char which represents the operator to an unsigned number, which is an unsigned number that represents the precedence. And we're gonna set it up. Can I just like do standard map like that? I hope. And then I already included map. Okay, I hope this works. And then I'm gonna need to change the precedence logic to look up this map instead. Here, instead of using this switch statement, I'm gonna do curtok unsigned press, and then I guess if I don't know what would happen if this lookup failed. In my past experience, I have had situations where if this fails, really bad things can happen. I'm gonna look at their code listing to see how they did it. Okay, so they did this. Oh, you don't actually have to assign to. You don't have to assign to it. It'll just get initialized, I believe. And then okay, so this is how they did this. Okay. Okay, so they have this little check. If it's not ASCII, then return -1. And then, oh, I don't really know why that's necessary if it's unsigned. It should not be signed. But okay. Alright. Oh, I use a different variable name than they did. Okay. Honestly, I don't think that's necessary. I'm gonna get rid of that. If it's needed, I may have to put it back later, but I don't think it's needed. Okay. Alright, go back to the main flow of the tutorial now. Let's see. Did we parse? This code? No. Okay, we were here. This is the Codegen for binary expression. We did that. We were working on this. Okay. Okay, we're working on this, and wait, is that right? Yeah, okay. And then now we have this map, which we're gonna add an entry to as we're generating the code for the function declarations. And then we're gonna have this code that creates the basic block for this function, etc. I don't think this code changes. Okay. Yep, we're registering the presidents in the president's table. All right, so that was binary operators. Next, we're gonna do unary operators. Unary operators doesn't look very long, so I'm just gonna do it. Hopefully, it doesn't take too long. Okay. We don't actually have an unary expert AST yet. Okay, let's add it. I'm gonna add it right after the binary one. Okay, an unary expression has the character represents the operator symbol, and then the operand, which is a unique pointer to the expression node that represents the operand, and this is just a constructor that allow the creator of this object to pass in those two pieces of information. And again, we're gonna have to declare the Codegen method as a override, and then later override it. Let's parse unary. Let me think. How do you know if it's unary or a binary? Oh, because we're gonna Trojan horse it into the binary, the parse binary up one. That guy will have to figure out whether it's an unary or not. Okay, that's interesting. But let's add a I'm gonna define the parse. I'm gonna define the parse unary function right above the parse binary up right hand side one. Left hand side or right hand side? Oh, I think this is saying I'm trying to understand this scheme. He's saying previously we have this parse primary. We're gonna replace this call to parse primary. This is parse right hand side, by the way. So this is like saying we're parsing this code that looks like this, and this parse expression is trying to parse this whole thing, but it's gonna first parse primary, and parse primary is gonna parse just this part, so it's gonna advance this pointer to over here, and then once the pointer is looking at the plus symbol, we're gonna call parse binary operation right hand side, as in right hand side as in this guy. This is guy's the right hand side, but I believe it also this symbol, this plus symbol, is still there where the cursor is pointing to, because this is getting the token precedence, and that can only work when we're still pointing to this plus symbol. So anyway, it's kind of saying the place where it was calling parse primary, we're gonna not do that anymore. We're gonna call parse Unary, because you could interpret this plus symbol as an Unary operator at this point. Okay, that's a weird way of looking at it. And then and then this is, guys, so parse Unary is gonna either defer to parse primary if it determines that the current token is not an operator, or if it is an operator, then it's gonna eat that symbol and then parse Unary again. This is actually more complicated than I thought. Okay. Okay. So since this is a little more complicated than I thought, I'm gonna stop this video here, and we'll complete this part in the next one. I'll see you there.